Unit 2, it's all about polynomial and rational functions. We're going to start off with quadratic functions. But before we do that, let's go back and just do a general definition of a polynomial function. So let n be a non-negative integer, and let a sub n and a sub n minus 1 and a sub n minus 2 and a sub all the way down to a sub 2 and a sub 1 and a sub 0. These are just like terms in a sequence. Let them be real numbers, and the first term's not 0. The function given by f of x equals a sub n times x to the nth, and a plus a sub n minus 1 times x to the n minus 1, etc., etc., etc. This is called the polynomial function of x with degree n. Essentially, it's a degree, or the degree is your highest exponent. So, in this section specifically, we're going to focus on second degree polynomials. And those are called quadratics. So, focusing specifically on quadratics, let's use this definition here. So it says the definition of a quadratic is, let a, b, and c be real numbers and a not equal to 0. Then the function given by f of x equals ax squared plus bx plus c is a quadratic function. Now, a couple things about the quadratic function. Not the quadratic formula, we'll get to that later. The quadratic function are AOS. You might remember those letters. Those stand for the axis of symmetry. To calculate the axis of symmetry, well, actually, maybe we should give a definition first. It's a vertical line that goes through the vertex. Oops. Of a parabola. So if we were to draw a rough sketch of that, here's a graph, here's a parabola. It's not my best parabola, it's not my worst, but a vertical line that goes through that. It cuts the graph in half. It creates some symmetry. It creates a reflective symmetry on each side of the graph. The equation we're going to need is x equals negative b over 2a, or the opposite of b over 2 times a. The vertex, we're going to use the coordinates, well, this part should look familiar, negative b over 2a, literally what we just had for the x, or for the axis of symmetry, and then f of negative b over 2a. So those are our x and y coordinates. Now, that second part looks way more confusing than I would say it really is. What this means is plug in the x coordinate. If we already know, first of all, we already know the x coordinate from the axis of symmetry, so we already have that half done, so this guy would go in here. That's already done. And then we just got to plug it in. Really, anytime you need to get an output for a point, you plug in the x value, you get the output. So that's the same for the vertex. Keep going on this page. We're asked to find the axis of symmetry and the vertex of the following quadratic functions. So the first one, the axis of symmetry, is x equals negative b over 2a. It doesn't really matter where that negative goes. I often put it up top. I'm going to put it out front for right now. But we should probably figure out what a and b are. So a is negative 3, b is 12, and then while we're at it, c equals negative 7. We're not using c right now, but it'll come in handy later. So plugging that in, we got negative, our b value is 12 over 2 times negative 3. I'm going to put that negative up top. So we got negative 12 over 2 times negative 3 is negative 6. So we end up with x equals negative 12 divided by negative 6 is positive 2. So that's our axis of symmetry. Now when you're doing axes of symmetry, make sure it's an equation for a line. It should be x equals something. If you just said the axis of symmetry is 2, I'm just going to assume you're talking about how much money I have in my wallet right now. I have $2. But no, it's x equals 2. It's a line. We got to make sure we're defining that. To find the vertex, the x coordinate we already have. It's 2. We just found that. To find the y coordinate, we're going to plug that in. We're going to do f of 2. So we'll do negative 3 times 2 squared plus 12 times 2 minus 7. That's a sloppy looking one. Let's try it again. 12 times 2. So we have negative 3 times 2 squared. Well, 2 squared is 4. Negative 3 times 4 is negative 12. 12 times 2 is 24 minus 7. So negative 12 plus 24 is positive 12, minus 7 gives us 5. So the y coordinate for our vertex is 5. So the axis of symmetry was the line x equals 2. The vertex is at the coordinate 2, 5. Take a moment, pause the video, see if you can do the same thing for h of x. And we're back. A value is -1. Remember, if there's no value written there, you can assume it's a 1. So negative x squared means -1 times x squared. B equals 4 and C equals 1. Axis of symmetry, x equals, I'm going to skip the writing out the formula. It's negative b, so we have -4 over 2 times our a value, which is -1. So we have -4 over -2, which gives us a +2, coincidentally, again. The vertex. So, sorry, finalizing that answer, just putting it as one succinct answer, x equals 2. Our vertex. We already know the x coordinate is 2. The y coordinate, we're going to plug that into the function h of x. So we got h of 2 equals negative, instead of x squared, we're going to do 2 squared. And I'll have to move my picture because I realize I'm about to cover up the writing. There we go. So we got -2 squared plus 4 times 2 plus 1. Well, 2 squared is 4, so -4 after we make it negative, plus 4 times 2 is 8, plus 1. After we clean it up, we get 5. So we have the coordinate 2, 5. Oh, my goodness, sorry. I already wrote the 2. So we coincidentally have the same axis of symmetry and the same vertex for these two equations.